Hello friends, welcome. Welcome to the video lecture series on control system. Myself Gaurav Rajwade. Today we will start with first lecture, which is nothing but introduction to the subject. Lecture agenda. First we will try to understand what are different topics we need to study in this subject, that is course outline. Then list of recommended books on control system. Then what are the prerequisites of the subject. Then actual introduction to the subject will start with the basic definitions and types of control system. Course outline. Basically in control system there are two parts. First is classical control system and second is modern control system. So out of them, in this course we will focus on classical control system, and modern control system we will learn in the higher semester. In classical control system, first module is system modeling. In this module we will cover transfer function, then mathematical modeling of physical systems, block diagram reduction techniques, and signal flow graph. So in short, we will learn what is transfer function and what are different techniques for representing transfer function. Then second module is system analysis. In this module we will cover time domain analysis, which talks about transient and steady state response. Then we will study different time domain parameters like delay time, peak time, rise time, settling time, peak overshoot, etc. These parameters comments on response of a system. Then after completing time domain analysis, we will study frequency domain analysis, which basically comments on stability of that system. In frequency domain analysis, there are different techniques like Bode plot, Nyquist plot, root locus, etc. we will cover. For this course, I refer mainly these two books. First is Modern Control System Engineering by Ogata and Control System Engineering by Norman Noyes. Other than these two books, there are so many books on control system like M. Gopal, Nagaraj Gopal, etc. Prerequisites for classical control theory. Differential equations we must know. We must know basics of physics and Laplace transform. And along with this technical knowledge, we required ordinary and semi-log graph papers. What is a control system? First, we will try to understand some daily life examples. While taking bath with the hot water through shower, normally we adjust water temperature with the help of knob. Means we will control flow of hot water as per our requirement. Also, nowadays if tank filled completely, then automatically supply gets stopped. Here float moment is calibrated with the inlet wall. So now we can say control system is a device or set of devices to manage, command, direct or regulate the behavior of the devices or system. Then we will move on basic definitions of different terminologies in control system. So first is, what is a system? We can say an interconnection of elements and devices for a desired purpose is nothing but system. Then what is a control system? Meaningful arrangement of components forming a system configuration that will provide a desired response. For example, if we want to control temperature of a room using air conditioner. Process: the device, plant or a system under control is nothing but process. The input and output relationship represent the cause and effect relationship of the process. Look at this block diagram. For the process, there are some inputs and there are some outputs. Then control variable. It is the quantity or condition that is measured and controlled. Normally, control variable is the output of control system. For example, room temperature. This is our output of control system in the case of temperature control in a room using air condition. Then manipulated variable. It is the quantity of the condition that is varied by the controller so as to affect the wall of control variable. For example, here in case of air condition, airflow or moisture level in air. These are the manipulated variable. Control. Control means measuring the value of control variable of the system and applying the manipulated variable to the system to correct or limit the deviation of the measured value from a desired value. Means if our set point is 20 degree and current room temperature is around 25 degree, so we measured control variable, that is a room temperature, and we will apply this information on air supply valve so it gets open more than previous case, so it will provide more cool airflow and it will try to reduce the temperature up to 20 degrees Celsius. So this is nothing but control or temperature control in a room using air condition. This is the simple block diagram where controller is installed, process is there. Controller, we can give input, set points or references. Then controller controls the manipulated variables and process gives the controlled output or controlled variable or desired output. But in this process we neglect one thing, that is nothing but disturbances. A disturbance is a signal that tends to adversely affect the value of system. It is an unwanted input of the system. If a disturbance is generated within the system, it is called internal disturbances, while an external disturbances is generated outside the system. Example is outside atmospheric conditions. So outside temperature, outside of room, if temperature is so high, it affects in the room temperature also. Or if there are so many people in a room, it also kind of disturbance. Then next is types of control system. Normally, first we will start with natural control system. So universe is a best example. Everything goes smoothly, controlled smoothly. Then human body. How does our body regulates temperature? Means always it remains around 37. So this is also natural control system. Then man-made control system. Aeroplanes, how they controls, how they land, how they take off. These man-made control systems. Then chemical processes, different chemical processes. Then next is a manual control system. Room temperature regulation, we just discussed. Then water level control. In diagram, man gets desired water level, so he's trying to shut down the wall. If desired water level is not reached, it remains open, means wall remains open. Then automatic control system. In our day-to-day life, we are using geyser, water heater, room temperature regulation via AC, even body temperature control. These are automatic. Then open loop control system. This is a very important classification. Open loop control system utilize a controller or control actuator to obtain the desired response. In this open loop control system, output has no effect on the control action because there is nothing like feedback. We are not at all measuring output quantity or output variable, so there is no effect on control action. In other words, output is neither measured nor feedback. So this is simple block diagram of open loop control system, which is nothing but without feedback system. Basic examples are washing machine, toaster, electric fan, microwave oven, etc. In open loop control system, it refers input is not compared with measured output. For each reference input, there is a fixed operating condition. Therefore, the accuracy of this system depends on calibration. So, we require calibration to get proper output. So, time to time calibration of that system is very important factor in this open loop control system. The performance of the open loop control system is severely affected by the presence of disturbances. Of course, we are not measuring output, so we don't have any idea how the external or internal disturbances affect on output. So it is insensitive with disturbances. Now next is a closed loop control system. It utilizes feedback. By looking at the diagram, block diagram, we can easily get output is measured and it get compared with input, then error generated which given to the controller, and controller manipulates the manipulated variables and process gives the output, which is nothing but control variable. It utilizes feedback to compare the actual output to the desired output response. So simple example is a refrigerator, and nowadays smart electric iron or automatic electric iron, air conditions. These are simple examples. The next is a multi-variable control system. Look at this block diagram. Instead of single input, there are so many inputs. Then comparator is there, controller are there. There are so many outputs, so we are measuring individual outputs. Then we compare all the output with input quantity. We are getting different errors for different parameters that fed to the controller, and controller gets proper action on manipulated variable, and those variables provided to process. So simple chemical example is oil industry. Raw crude oil is utilized to get kerosene or LPG or other chemicals, even petrol, diesel. So these are multiple inputs and multiple out. Simple example of multivariable control system. Then feedback control system. That is nothing but closed loop control system. The system that maintains the prescribed relationship between output and some reference input. By comparing them and using the difference, or we can say simply error, as a means of control, is called feedback control system. Feedback can be a positive or negative. There are two types of feedback control system. If we added that feedback to the input, then it is a positive feedback, or we subtract it, then it is a negative feedback. Normally, if we use negative feedback, the whole whatever be the process, so total gain of this system get reduced. But if we use positive feedback, that gain get increased. Next is a servo system. A servo system or servo mechanism is a feedback control system in which the output is some mechanical position. This is very important. Output is mechanical position or velocity or acceleration. So antenna positioning system, simple example of servo system or servo mechanism. Then modular servo system is shown in figure. So in day-to-day life, solar tracker or antenna, we are adjusting this for communication purpose or to get proper electricity through solar panel. Then linear versus non-linear control system. A control system in which output varies linearly with the input, it's called linear control system. So in this process, if input is u of t and output is y of t, and there is a linear relationship between y of t and u of t, then we can easily say this is linear system or control system. So graph, by looking at graph, we can easily comment on these two equations. These are linear equations, of course. When the input and output has non-linear relationship, the system is said to be non-linear. By looking at graph, we can easily say this is not at all linear. Time invariant versus time variant. When the characteristics of the system do not depend upon time itself, then system is set to the time invariant control system. For example, y of t is equal to minus 2 u of t plus 1. Here it's not depends on time. So this we can easily say that or comment that this equation is nothing but time invariant control system equation. Whereas time varying control system is a system in which one or more parameter vary with time. So y of t is equal to 2u of t minus 3t. So in this case 2u of t is independent of time, but minus 3t, this second parameter is, or second quantity is depend on time, so whole y of t is depend on time. So we can easily comment this equation nothing but time varying control system equation. The next classification is continuous data versus discrete data system. In a continuous data control system, all system variables are function of continuous time t. Look at this graph, x of t versus t means time. So at every instant of time you get some finite output or x of t at every instant. But whereas in second figure, which is nothing but n versus x of n, their output is present at particular instant or particular sample. So this is nothing but discrete time, and first diagram is nothing but continuous time. So continuous data control system, all system variables are function of continuous time t, whereas a discrete time control system involves one or more variables that are known only at discrete or particular time intervals. Next is deterministic versus stochastic control system. A control system is deterministic if the response to the input is predictable and repeatable. So here, by looking at diagram x of t versus t, we can easily say that it is a deterministic response. Y of t is nothing but repeatable, predictable and repeatable response. It continuously repeats after some interval. Whereas in z of t versus t, it's not at all predictable and it's not at all repeatable also. So this we can easily say example of stochastic control system. So overall in this lecture we started with control system, then we classify mainly control system into natural and man-made. In man-made also we classify into manual and automatic. In automatic there are two classification is nothing but open loop and closed loop. In open loop we classify open loop system into non-linear and linear. Even closed loop system we classify into non-linear and linear. In non-linear we classify system into time variant and time invariant, and linear system we classify into time variant and time invariant. So after this lecture we have to concentrate only on this section, that is nothing but linear time invariant control system. So thank you for watching this video. In the next lecture we will start with lecture 2, that is nothing but transfer function and stability of linear time